This is Euclid Book 10, proposition number 81. And it says the following. To a second apotome of a medial straight line, only one medial straight line can be annexed, which is commensurable with the whole in square only, and which contains with the whole a medial rectangle. Now you're probably sitting there going, what in the thunder is he talking about? Okay. Let AB be a second apotome of a medial straight line. So now we're going to show you AB. Well, this is AB right across here. This is going to be a second apotome. And BC is going to be an annex to AB. Okay. Therefore, AC, this whole length right here, and BC, both of these lines, the whole and this part, are medial straight lines. They're commensurable in square only. Okay, so they're not commensurable in length, but they are commensurable in square. And such that the rectangle ACCB, which they contain, is medial. Okay, well this is the rectangle ACCB. Two sides of this rectangle are going to be the length of AC, two sides are going to be the length of BC. And I'm sure we have been through this many times before, but this square right here, all four sides are the length of AC. This square right here, all four sides are the length of CB. This square here, all four sides are the length of AB. This square here, all four sides are the length of AD. This square here, all four sides of the length of DB. Over here, we have a rectangle. Two sides of the length of AD, the other two sides of the length of DB. So now we know where we get all that from. Let's go on. I say that no other medial straight line can be annexed to AB, which is commensurable with the whole in square only, and which contains the whole, which contains with the whole a medial rectangle. For if possible, let BD also be annexed. So now we're going to annex BD to AB. Therefore, ADDB. Okay, well here's AD and here's BD. They are also medial straight lines. They are commensurable in square only, and such that the rectangle ADDB, which is this one right here, which they contain, is medial. This rectangle is medial. This is by Euclid Book 10, proposition number 75. But a rational straight line EF be set out. Well, this is the rational straight line EF. Let EG, okay, so now we have a rectangle, okay, and this is the rectangle EG, so it's EFGM, this whole rectangle right here. It's this piece plus this piece combined, this whole thing. Okay, now the area inside of all of this is the same amount of area as something else. What is it equal to? Okay, so if we take the area of AC and we add it to the area of CB, okay, then that sum is going to be the same amount of area as what's in here. Now, we're applying this EG to EF. And we're now going to produce EM as the breadth. That's this. Let HG, okay, now we have an HG, this rectangle right here, which is HLGM, this one right here. Not this, just this, okay? The area inside of here is equal to twice the area of this. So if you multiply this area by 2, you get this area right here. Okay? Now what we're going to do is we're going to subtract HG from EG. And when we subtract HG from EG, first of all, we're going to say that HM here is the breadth of HG. That's what we're going to say. Therefore, the remainder EL, that's this one right here, EFLH, this remainder right here, is equal to the square on AB. So the area inside of this is the same as the area inside of this. This is by Euclid Book 2, proposition number 7. So that AB is the side of EL. Okay. So now we're going to say that this length here is the same as this. Again, let EI, okay, now we have EI. Well, that's this area plus this area plus this one. All three of these areas combined. That's EI. It actually ends up being EFIN. Okay. Now, that whole area is going to be equal to something. What is it going to be equal to? Okay, so what we're going to do is we're going to take the area inside of this and the area inside of this. We're going to add those two areas together. And when we add those two areas together, it's going to be the same area as this whole thing. Okay? Alright, and that's going to produce EN as the breadth. EN is the breadth of all that. But EL is also equal to the square on AB. This is equal to this. Therefore, the remainder HI, what's the remainder HI? That's this area plus this area, this whole thing right across here, okay? That is equal to twice the rectangle ADDB. So if we multiply this times 2, we get all of this area here and here. This is by Euclid Book 2, proposition number 7. Now since AC and CB are medial straight lines, okay, now we've already said that this is a medial straight line and this is a medial straight line. Therefore, the squares on AC and CB are also medial. Okay, these are medial areas. And they are equal to EG. Okay? Now then, what is EG? It's this plus this. Okay? So what we're saying is, if you add this area and this area together, you get this. Okay? Therefore, EG is also medial. This is by Euclid Book 10, proposition number 15, and Euclid Book 10, proposition number 23, porism. And it is applied to the rational straight line EF. It's applied to this. Producing EM as the breadth. That's this. Therefore, EM is rational. This line from here to here, that's rational. And it's incommensurable in length with EF. Okay? So this line is incommensurable with this. This is by Euclid Book 10, proposition number 22. Again, since the rectangle ACCB is medial, this is a medial rectangle. Twice the rectangle ACCB is also medial. So if you multiply this area by 2, it's still medial. This is by Euclid Book 10, proposition number 23, porism. And it is equal to GH. Well, what is GH? Well, that's this LHMG. That's this area right here. Okay? So, twice the area of this rectangle is going to be equal to this. Now, correction. The area of this rectangle is going to be equal to this. Alright. Therefore, GH is also medial. And it has been applied to the rational straight line EF, producing HM as the breadth. Therefore, HM is also rational and incommensurable in length with EF. This line is rational and it's incommensurable with this. That's by Euclid Book 10, proposition number 22. And since ACCB are commensurable in square only, so as this length and this length are only commensurable in square, therefore AC is incommensurable in length with CB. Well, we figured that out already. But as AC is to CB, as this whole line here is to this whole line, so is the square on AC, which is this, to the rectangle ACCB. So as this is to this, so as this is to that. Therefore, the square on AC is incommensurable with the rectangle ACCB. This is incommensurable with this. This is by Euclid Book 10, proposition number 2. But the squares on ACCB, these two right here, you add them together, they are commensurable with the square on AC. Okay? If you add these two together, they're commensurable with this. While twice the rectangle ACCB, now we're going to take this area and multiply it by 2, is commensurable with the rectangle ACCB. So twice of this is commensurable with one of this. This is by Euclid Book 10, proposition number 6. Therefore, the squares on ACCB, that's these two right here, we're going to add them up. That total is incommensurable with twice of this area. This is by Euclid Book 10, proposition number 13. And EG, okay, so now we're back to EG, that is this area plus this, these two together. Okay, that is equal to the squares on ACCB. This whole area equals the sum of this and this. While GH, okay, what is GH? That's from here to here. HL, GM, that's this area right here. How much area is in here? Well, it's, if you multiply this area by 2, you get this. Therefore, EG, which is this plus this whole thing, is incommensurable with GH. So the whole thing is incommensurable with just this right portion right here. Okay? But as EG is to GH, as the whole here is to this part of it, so is EM to HM. So is this to this. That's by Euclid Book 6, proposition number 1. Therefore, EM, okay, this plus this together, that's EM, is incommensurable in length. Okay, so this whole length right here is incommensurable with MH. This is incommensurable with this. That's by Euclid Book 10, proposition number 2. And both are rational. This whole line is rational. This part is rational. Therefore, EM and MH are rational straight lines commensurable in square only. Therefore, EH is an apotome. Okay? This is an apotome. And HM an annex to it. So we're going to annex this to EH. Okay. Similarly, we can prove that HN is also annexed to it. So now we're going to annex the whole HN. Therefore, to an apotome, different straight lines are annexed which are commensurable with the holes in square only, which of course is impossible. And this is by Euclid Book 10, proposition number 75. I'm sorry, Euclid Book 10, proposition number 79. And that's the end of the proof. I told you this one's going to be big. Alright, I will tell you more in a future video. Stay tuned.